Are we alone in the universe? For centuries, that was a question for philosophers and poets. But today, it's a question for astrophysicists and astronomers. And they're not just wondering anymore, they are actively hunting. So today, let's join that hunt, the incredible scientific quest to find another Earth. Okay, so before we can find another Earth, we need to know what we're looking for, right? What are the absolute non-negotiables for a world that could support life? This question, it's not just some academic exercise. It's the compass that guides the entire search. I mean, think about it. When you're searching the entire cosmos, you can't just look everywhere at once. The hunt for exoplanets, that's planets outside our solar system, starts by narrowing things down. Astronomers focus on a really specific region around each star, a place that's, well, just right. It's officially called the habitable zone, but you probably know it as the Goldilocks zone. And the key ingredient here, the whole reason for the name, is liquid water. As far as we know, water is the universal solvent needed for the chemistry of life to happen. You get too close to the star, and all that water just boils away. Too far, and it's frozen solid. This zone is that perfect sweet spot where life's most essential ingredient can actually flow. And you know what? We don't even have to look that far to see this in action. Just look at our own solar system. Venus, our neighbor on one side, is a scorching hot pressure cooker where water just can't exist as a liquid. And Mars, on the other side, is a frozen desert. We're the lucky ones, living right in that life-giving zone where our oceans can exist. So, armed with this Goldilocks principle, astronomers started the hunt. And believe it or not, one of the most promising candidates they ever found was practically right on our cosmic doorstep. That's right, just 4 light years. In galactic terms, that's not just in our neighborhood. That's like being in our front yard. This discovery really lit the fuse for the modern hunt for Earth's twin. And the profile of this world, Proxima Centauri b, was just staggering. It's a rocky planet about the same size as Earth, and it orbits smack dab in the middle of its star's habitable zone. This was a huge discovery, a confirmed Earth-sized planet in the Goldilocks zone of our closest stellar neighbor. Amazing. It was an incredibly exciting moment, but as you know, science quickly follows excitement with some tough questions. Is location really everything? Does being in the right zone automatically make a planet a paradise? Well, the answer, it turns out, is a lot more complicated. Yeah, it turns out orbiting in the Goldilocks zone is just the first checkpoint on a pretty long list. A planet's address is important, sure, but its neighborhood, and especially its landlord star, can make all the difference between a paradise and a total death trap. Proxima Centauri b orbits a red dwarf star, which is way smaller and cooler than our sun. That means its habitable zone has to be snuggled up really close. But that closeness creates 2 gigantic problems. First, red dwarfs are famous for throwing these violent temper tantrums, flares that would blast a nearby planet with life-sterilizing radiation. And second, the star's intense gravity causes something called tidal lock. A tidally locked planet is just like our moon. It always keeps the same face pointed towards its star. So just try to imagine that. A world with one side in permanent, scorching daylight and the other side locked in a permanent frozen night. If life existed there, it would have to cling to this tiny sliver of twilight between the 2 extremes. A very, very tough place to live. The issues with Proxima b were definitely a reality check, but they didn't stop the search. In fact, they just pushed astronomers to look even further out. And soon, they found a system that multiplied the possibilities in a way that nobody expected. The next huge discovery was an absolute stunner. Not 1, not 2, but 7 planets, all roughly the size of Earth, all orbiting a single tiny star called TRAPPIST-1. It wasn't just a new planet, it was a whole new solar system of possibilities. It was like hitting the exoplanet jackpot. And here's what makes the TRAPPIST-1 system so revolutionary. Of its 7 rocky worlds, a stunning 3 of them orbit inside the star's habitable zone. That's 3 different chances for liquid water, 3 potential cradles for life, all in one place. For scientists, this is an absolute dream. It allows them to compare multiple potentially habitable worlds at once to see what makes one tick versus another. So, finding these worlds, that was just phase 1. Now, the hunt is entering a brand new, even more exciting era. We're moving beyond just finding the real estate, and we've started looking for signs of the tenants, the telltale signs of life itself. Thanks to some incredibly powerful new tools, we can now do something that honestly sounds like science fiction. We can analyze the air on planets that are light years away. The goal is to find what are called biosignatures, the chemical evidence that life is actively changing a planet's atmosphere. So, how does this actually work? It's a brilliant technique. As a planet passes in front of its star, from our point of view, a tiny bit of the starlight shines through its atmosphere. Powerful telescopes like the James Webb Space Telescope can catch that light and break it down. And certain gases, like oxygen or methane, leave a specific chemical fingerprint in that light, telling us exactly what's in the air. And this is the grand prize. Finding oxygen is a really big deal because here on Earth, our oxygen-rich atmosphere is almost entirely a product of life, all the plants and algae doing photosynthesis. Finding a bunch of oxygen on another world wouldn't be absolute proof of life, but boy, it would be the most revolutionary signpost in human history, pointing to the real possibility that we are not alone. And that brings us to the final and maybe the biggest question of all. After all the science, all the searching, if we do find evidence of life, even if it's just simple microbes on another world, what would that mean for us? How would that change our understanding of our own place in the cosmos? Now that is something to think about.